Okay, next point. One of your objectives in your conclusion and evaluation is to talk about precision and accuracy. And when you talk about precision and accuracy, you need to know all of the things that are shown on this page. And we usually describe it using what's basically a dartboard because it helps us to visualize what we're talking about. It also links in with your random error and your systematic error. So make sure you understand what the random error and the systematic error is. If you're not sure, random error is something that occurs that was unexpected and it might change the value in different ways. I'll see if I can fit that in. And a systematic error is one which is also not necessarily expected, but it always would have the same effect on your values. I'll give you an example. So, if for example you said there was always a bit of aspirin powder left in my weighing boat, so not all of the aspirin powder went into the titration, that one would be a systematic error. And it would be because each time you lost a little bit of powder. You never ended up with too much powder. That would be a random error because the values would change in different ways. But here you're always losing a little bit, so you always have the same effect on the values. The values are always going to be, I'm not going to tell you which way they would be, but it's always going to be the same. That's the difference between a random error and a systematic error. Because systematic is always going in the same direction, we can then look at it at the end and say, okay, my value is a little bit bigger or a little bit smaller than the published values. Maybe that's because of a systematic error. The random errors are improved by repeating your measurements because they change the values in different ways. So if you like, it might give you this dartboard here in the middle where your values are spaced around the real value because each time something happened that affected the values in different ways. They didn't all go in the same direction. Okay, let's look at the dartboards and see how they relate. So on the left here we have your ideal scenario where you have perfect data. All of your darts are in the middle. That means all of the values that you have achieved in your experiment match up almost perfectly with the published value. This means it's accurate and it's precise because you've got low random error, they're not spaced around, and low systematic error, they're not shifted off in one direction. And in blue there I've written what that means. Data is similar and close to the published value. In the middle here we've got another dartboard, and this one is accurate but not precise. Okay, so what does accurate mean? Well, accurate means that if we took the average of these values, which is what you usually do when you have three values in an experiment, we would find that they would kind of end up in the middle because they're kind of evenly spaced around the middle. So they're accurate, but they're not precise. Precise means that they're all together, that when we look at our data values, for example your titrations, you've got three values that are really close together. We can see that here, for example, and we can see that here. This one is not precise. The values are not close together. This means that you've got a higher random error. Remember, random error means the values are changing your measured values in different ways, but you've got a low systematic error. The systematic error here would change the values from the published value. They're not. If you average them, they give you pretty much the published value. In blue, I've explained that here. When averaged, repeated readings to minimise the effect of random errors, your data ends up close to the published value. The third one over on this side, we can see that the darts are close together, but they're not very close to the published value, which is in the middle. So these are precise. Precise means that your values are close to each other. You have carried out your experiment a number of times and your results are they agree with each other very well. But it's not very accurate because it's not close to the published value. If it's not close to the published value, but all of them are close together, that means you're likely to have a systematic error. Remember, systematic error means it has the same effect on all values. So, for example, you left some powder in your weighing boat, therefore your values weren't quite at the published value, but they were all close together because you did your titration very carefully. So they're all over here. it means that your data is similar to itself, but it differs considerably from the published value. So when you do your experiment write-up, when you look at your conclusion evaluation, you have to look at your data and you have to decide which of these 3 dartboards is your data most like. And then please don't copy my words exactly, but use that idea to explain whether you think you've got high or low precision and high or low accuracy. It's another evaluation point for your experiment. Okay, this is another statement here. Here from your conclusion evaluation. It says, the magnitude and direction of any systematic uncertainty is stated. What does that mean? Well, magnitude, basically means size. So the size of the uncertainty is stated and the direction. Okay, let's have a look. What is this statement then asking you to do? So, for example, we've already discussed a possible systematic uncertainty from this experiment, and we said some powder left on the weighing boat. So what do you think this systematic error might do to the final calculated value of aspirin? Well, what we're talking about here is the direction of the uncertainty. So the direction. Basically, we're saying, is it going to make the value you've calculated larger, or is it going to make the value you've calculated smaller? I'm not going to tell you what I think the answer to that question is, because that's part of what you're writing up. But that would be the direction. So if you want a direction, you have to say basically, bigger or smaller, your final value. That's the direction. The other part of this is the magnitude or the size, and I've written here, how important do you think this factor was in explaining the difference between your calculated value and the published value? So for example, if we've got our dartboard over here, here's the published value in the middle, maybe your value's over here somewhere. So you've got a clear systematic error there. There's this distance here between the published value and your value. How important do you think the factor of some powder left on the weighing boat was in creating this distance here? Was it the main reason? Do you think that that was the main reason your value was different? You should also then think about your bigger or smaller. Maybe you have your value, if you've done some sort of graph, maybe your value was this big and the published value was smaller. So you ended up with a value that was too big. Does this factor we've looked at here contribute to that? Would it make it a bigger value, or would it in fact make it a smaller value? If it would make it a smaller value, then this probably isn't the main reason for the error that you've seen in your calculations or in your measurements. What they basically want you to do here is to almost rank your systematic errors by how important they are. So if you've, for example, identified 4 or 5 systematic errors that happened in your experiment, you need to rank them. You need to say, I think this one was the most important, then this one, then this one, then this one. Or I think these 3 had a very small impact, or maybe their direction was completely wrong, so they definitely didn't have any impact on the fact that my value is too big. You need to start discussing your errors in that way. Lots of you've done a really good job of identifying your errors and saying this is a systematic error, this is a random error, this is a systematic error. You just need to take that one step further now and look at the size, which one is the most important, and the direction. Is it going to make it bigger? Is it going to make it smaller? And that will give you quite a lot more to write about, as well as making your report much better. There's a question here for you to think about. I'm not going to give you the answer right now. Why do they not ask us to treat random errors in the same way?